If you book a flight from New York to London today, you will arrive at exactly the same time as a passenger making that trip in 1958. We've spent the last half-century optimizing passenger jets for safety, capacity, and fuel efficiency, but the actual speed of commercial flight has steadily decreased. There is one glaring exception. For 27 years, a single aircraft defied this slow retreat. The Concorde crossed the Atlantic in about 3.5 hours, cruising at Mach 2.04 more than 1,300 miles per hour. Pushing a passenger plane past the sound barrier required throwing out standard aerodynamic principles. A conventional wing with standard flaps simply will not work at Mach 2. Engineers had to invent the slender ogival delta wing, a structure that generated specialized spiral vortices to create lift at lower takeoff speeds, while maintaining extreme aerodynamic efficiency at supersonic cruise. Cruising at 60,000 feet, generated so much aerodynamic friction that the outside air could be negative 56 degrees Celsius, while the aluminum skin heated to over 120 degrees. The metal absorbed so much thermal energy that the entire aircraft would literally stretch by 8 inches mid-flight. But operating on the bleeding edge of physics came with a steep cost. Concorde burned 22 tons of aviation fuel every hour to carry 100 passengers. The ticket prices were massive just to break even. The conventional history states that a tragic crash in the year 2000 finally killed the supersonic dream. But the data tells a very different story. Concorde was economically assassinated decades before it ever caught fire. As a joint venture between Britain and France, this aircraft bypassed the massive American aviation monopoly. It challenged the entire existing global aerospace hierarchy. That made it a target. When Britain and France signed the treaty to build a supersonic airliner in 1962, the United States aviation industry panicked. Congress funded a massive Boeing project to build an even faster, 300-seat supersonic transport. After burning through $1 billion, the U.S. government canceled the project without ever producing a single working aircraft. American carriers suddenly faced a future where they had no supersonic aircraft of their own and no ability to build one. 2 years after abandoning their own project, the Federal Aviation Administration outlawed all commercial supersonic flight over the United States. The stated justification was noise. Traveling faster than sound generates a continuous shockwave. Military testing over Oklahoma City had resulted in thousands of legal claims for shattered windows and cracked plaster. The sonic boom was a real physical problem, but the blanket ban implemented in 1973 didn't set a noise limit. It outlawed the entire category of flight. Dozens of other countries quickly followed suit. A plane explicitly designed to operate a highly profitable global network was suddenly locked over the ocean, physically restricted to a single viable commercial corridor between London, Paris, and New York. The geographic restrictions crippled the business model, and then the 1973 oil crisis hit. The OPEC embargo quadrupled global fuel prices almost overnight, destroying the math of high-speed travel right as Concorde prepared to enter commercial service. This chart comparing passenger fuel efficiency illustrates exactly why the airlines backed away. At the height of the oil crisis, Concorde achieved 15.8 passenger miles per gallon. The newly introduced subsonic Boeing 747 achieved 46.4 miles per gallon while carrying 4 times as many people. Airlines canceled their pre-orders by the dozens. The projected market of 350 planes instantly evaporated down to 14. Regulatory barriers trapped the aircraft geographically, and the oil crisis starved it financially. The aircraft flew its transatlantic routes safely for 24 years, until the afternoon of July 25, 2000. Air France Flight 4590 began its takeoff roll down runway 26 right at Charles de Gaulle Airport in Paris. 5 minutes earlier, a Continental Airlines jet took off from the same runway. During its acceleration, a titanium wear strip, which had been improperly substituted for a stainless steel part during maintenance, separated from the engine housing and fell onto the asphalt. As the Concorde reached critical takeoff velocity, its left main landing gear ran directly over that robed titanium strip, shredding the tire and launching dense, heavy rubber fragments upward at extreme speeds. The debris didn't pierce the fuel tank above the wing. Instead, the sheer kinetic force of the impact struck the metal exterior with such violence that it sent a shockwave through the completely full fuel tank, rupturing it from the inside out and instantly igniting a massive fire. All 109 people on board and 4 on the ground died. The crash investigation revealed deep flaws and maintenance oversights, but the accident was ultimately a catalyst. The industry used a freak debris strike to permanently shut down an expensive program they had wanted dead since the 1970s. Retiring Concorde triggered a complete surrender in the pursuit of speed. Airlines and manufacturers pivoted exclusively to high-bypass turbofan engines, which provide massive efficiency gains but strictly limit aircraft to speeds well below the sound barrier. The 1973 ban on overland flights created a 50-year innovation desert. Without a legal way to fly supersonic routes, aerospace companies had zero financial incentive to develop quieter engines or study sonic boom mitigation. The institutional knowledge required to build these machines was completely scattered. That drought is finally ending. NASA and Lockheed Martin built the X-59 Quest, a radical experimental aircraft designed specifically to solve the physical problem that got Concorde banned in the first place. By heavily modifying the geometry of the plane and stretching its nose to account for a third of its entire length, engineers figured out how to keep the shockwaves separated. Instead of merging into a destructive double crack that shatters windows, the X-59 produces a gentle thump, roughly as loud as a car door slamming. Concorde proves that technological progress is not a guaranteed straight line. The aviation industry retreated into slower, cheaper designs because political boundaries and economic shocks dictated the rules. But the technology currently taking flight in the California desert shows that we can choose to rewrite those rules and accelerate once again.